All right, guys. So I know it was kind of a weird video, but again, it's very random. But the thing that I do love, sorry about that. I know it's kind of a very random video, but one of the things I love most about math is that when you're solving an equation, everything kind of follows in order. And I've always loved this since I was a little kid. And I love how when it's like a chain reaction. When you do one step, all these steps kind of follow it in suit. So when I saw that video, it made me kind of think of the way I love math because, when you're solving these problems, they can get boring at times, but if you make it into a game where it's like, hey, if I do this, I get this, it makes something more entertaining for you, and then you'll like it more. So today we're going to take a look at our next section of our notes, the converse of the Pythagorean Theorem. So we know what the Pythagorean Theorem is, okay? The sum of the two sides of a right triangle squared will equal the hypotenuse squared. Well, the converse is basically saying that if you can prove this first, okay, if c squared equals a squared plus b squared, then we can say it's a right triangle. So let's look at this formally. If the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So that's basically what we're doing. We're proving this is a right triangle. Now the good news is we're not doing a formal proof here, but you're basically using Pythagorean theorem to show whether or not a right triangle is there. Okay, so let's take a look at number one here. Tell whether the triangle is a right triangle. Our first goal, as you will probably come to love and appreciate the next couple of days, is find your hypotenuse. So across my right angle, okay, well, assuming this is our right angle, if this is the right triangle, this would be your hypotenuse. For these problems, since we don't know exactly what the right angle is, you're just looking for the longest side. Okay, so 65 is the longest. Here are my two legs, which I'll call A and B. We know a squared plus b squared equals c squared. So 33 squared plus 56 squared equals 65 squared. Okay. Now I'm using strictly calculator here because off the top of my head I do not know what 33 squared is nor 56 squared. So I know 33 squared gives me 1089. I know 56 squared gives me 3,136. 65 squared is 4,225. All right, so I'm adding together 1,089 plus 3,136. And in order for this to be a right triangle, these have to equal each other. Which, if we take a look, do the math, we can see it does. So we've just done a little bit of work here. We can say yes, this is a right triangle. Okay, so it's nothing too drastically different than what we've been doing. It's just that now we're kind of verifying that this is indeed a right triangle. Okay. Again, looking here, longest side is kind of easy to recognize. Here it is. Here's my hypotenuse C. So we've got 2 root 38 squared plus 10 squared equals 16 squared. Now that's something that we've shown in the homework before, and I think some of you guys are getting this pretty good. But 2 root 38 squared, you're squaring the number out front. So if you square 2, we get 4. When you square the square root of 38, we end up getting a number very, very large. Let me show you this real quick. 38 squared is 1,444. But look what happens if I square root that. We get 38. Here's the neat thing. The square root of any number squared gives you the numbers underneath it. So in this case, it's 38. Plus 100 equals our 16 squared is 256. All right. Now, 4 times 38, 152. So 152 plus 100. If I add those two together, does 252 equal 256? The answer is no. Therefore, this is not a right triangle. Okay, this would be something else instead. All right, that's the whole point of this converse of the Pythagorean theorem. Okay, fairly simple, nothing new, really, just kind of verifying if it is or not. All right, so let's flip to our back. Now these are two very, very important theorems, all right? And probably some of the most important theorems for the first three sections here. But basically, if you do Pythagorean theorem and you see that if c squared, okay, your hypotenuse of the biggest side squared is less than the two smaller sides squared added together, then you're verifying the triangle is acute. If your c squared is greater than your two smaller sides squared, then your triangle is obtuse. Okay? So now, just to kind of show you guys again, I'm flipping back to the other side. Right here, we saw that c squared was larger than a squared plus b squared. This triangle up top, then, by the theorems we just learned, would be obtuse. Okay, because our c squared is larger. All right? So we're going to take a look at, down here, a few examples of this. Decide whether the set of numbers can represent the side lengths of a triangle. If they can, classify them as right, acute, or obtuse. Well, here we go. Look for your largest side. In this case, 48. Okay? So we're going with 28 squared plus 40 squared, and we're trying to see, I'm going to put equal sign with a question mark over it, 48 squared. Because I don't know. I'm trying to find out. Let's do a little bit of calculator work here. 28 squared. 40 squared, 48 squared. So 784 plus 1600. See if it equals 2304. Okay? 784 plus 1600 equals 2384. And then this is 2304. So which one's bigger? Well, 2384 is larger. Because this was your a squared plus b squared, this would make it a acute triangle. All right? So we're just working our way through these. Our largest side is 12, C. 9 squared plus 6 squared. See if it equals 12 squared. Okay? So we got 81 plus 36, seeing if it equals 144. Now in this case, 81 plus 36, 81 plus 36 gives me 117. 117 is less than 144. Therefore, your c squared is larger. This would be obtuse triangle. Okay? So far, so good. Now, take a little bit longer down here to look. 34, 16, and 30. Okay. For this one, you're taking a look. Your largest side is 34, so there's your C. You can throw you off every once in a while. 16 squared plus 30 squared. See if it equals 34 squared. All right, 16 squared. Here's your 30 squared. Here's 34 squared. So we got 256 plus 900. Seeing if it equals 1156. 256 plus 900 gives you 1,156, which equals 1,156. Oops. Sorry, I got this whole thing pop up on my computer. Go away. All right. Because they equal each other, this would be a right triangle. All right. Now, the one thing, this last one, you might be inclined right away to go, oh, C is 22, let's go with it. However, the one thing that I didn't check with the other ones, okay, maybe you've noticed this, maybe you didn't, it says decide whether the set number of numbers can represent side lengths of a triangle. If we look at part D, you see how it's 8 and 13 gives you 21? Is 21 larger than 22, the third side? If your answer is no, which out of all four of these examples, this is the only one there, these would not form any kind of triangle. Okay? Just won't work. This is a theorem we learned 2 chapters ago, but the two smaller sides must be larger than the third side. Okay, so if you take a look right here, these 4 examples, this is everything I can possibly throw at you, every possible example. All right, this is definitely something you will see again. But in this short little video, we've shown the entire notes with the converse of the Pythagorean theorem and also our 2 theorems to back it up as far as proving acute and obtuse. As far as that goes, hopefully everything went well. Ask any questions, feel free to do it at the end of the period. And as always, good luck. We are all counting on you.